Right. Hello. Um, so today we are going to have a look at no. Yes. Okay, so we're going to have a little multitasking in operating systems. So obviously, operating systems we've already they're a platform. They're basically a platform from which you can run different applications. And what I mean by applications, and we talked about this before, we're talking about programs. Okay, simple as that. They run programs. Sorry, I'm just going to make this bigger. There you go. Okay, they're applications like programs. Okay, so the idea is they can run multiple applications at the same time. Okay, and different operating systems will have different capabilities with regards to running multiple applications at the same time. Okay, so the ones that we're going to talk about, the ones that we've talked about in the previous videos, are called multitasking OSs, okay, or MTOS. Okay, so they're all the ones you're usually familiar with. Okay, so we know that the OS helps the CPU, okay, and it to multitask, and it does this really through managing the memory, basically. Okay, so it helps to run the applications. These are called multitasking operating systems, and the operating system, if it's a multitasking one, helps the CPU to multitask by managing the memory, and most importantly, by managing CPU processing time. And we've looked at that in the previous video, okay? Clock speed and all that. So how does it do it? When an application is opened, so when you open an application, step one, when you open an application, okay, the OS moves the necessary bits, for want of better words, to the memory. And then the additional bits. When required. Now you might think, well, why does it not move the whole lot? Well, it doesn't make sense to move the whole lot because you have only a certain amount of memory. So for example, you open Microsoft Word, for example, there's an application, a nice one, a lot of people would use it, okay? It doesn't move the entire file that contains the entire program. It opens up the bits that you are most likely to be using right then. And then if you need something else, it moves it in to the memory, okay? And if a bit is not being used recently, it moves it out of the memory. Now you're thinking, how the hell does it do this? Well, first of all, the software developers have developed their software to be compartmentalized so that bits can be moved off them. So let's say this box contains the entire piece of software from Microsoft Word. It's not just one box. It contains lots of different parts of the program, and only a certain amount of the program is necessary for it to start up, come up on your screen with the tab on the top and the ruler down the side. It's only when you start clicking on buttons that other bits are called in to do that. And the more rare the button, or the more unusual or the less frequently things that are being used, the more likely it is that they're not going to be transferred over into memory straight away. Okay, so I hope that makes sense to you. The actual typing bit of it and words appearing is probably moved over. But for example, inserting an unusual symbol, or inserting an equation, or creating a table, or new background, or orientation, those things are probably not moved in. I don't know whether they are, but some of those things won't be moved in, and they'll be necessary for it to be called from the program into the memory as needed. Okay. Now, unusually, and this is probably something you don't realize, but only one app at a time in the CPU. Okay? So, one CPU can really only deal with one app at a time. Okay? Which sounds a bit kind of, well, wait a second, that doesn't make sense. I can have 20 different apps open at the same time. You might have them open at the same time, but what you don't realize is the other processes that are happening while one thing is actively being used are just waiting. Okay, and the operating system divides the CPU time between open applications and can prioritize certain processes for instructions. Okay, in order to execute the most efficient order. Okay, so this is the beauty of the operating system. The CPU and all its amazing things it can do. It's like a team of great footballers. The reality is you still need a manager to actually tell them what position to take, which moves to take, depending on which scenarios. So that's the best kind of analogy I can come up with. Okay, for anybody into your basketball, it's a different, or American football, it's the plays. It's the plays that are actually, that the manager teaches the players to apply under certain conditions. So the operating system has a number of different plays in its playbooks depending on what applications are being used and what's the demand on the CPU at any given time. Okay, so, and obviously when required, the operating system can make decisions like to move data to and from virtual memory if it thinks it needs that in order to get over a hump, for want of a better word. So that's another issue that can come up with it. So that's how it can deal with kind of multitasking. So you can see why the operating system is really, really important, for want of a better word. Okay. Now, it's also the job of the operating system to make sure that the files are what they're meant to be. Okay. So when you look for example, money.py, or diary.docx or whatever, when you're looking for those file extensions with those file names, it's up to the operating system to make sure that A, you can find them, and B, they're somewhere where they're to be found. Okay, so the operating system does actually handle file and disk management as well as everything else. Okay, so obviously computers store data on files. This is known. Okay, whether it's image or music or videos or spreadsheets or Word docs or everything, they're just collections of data. So file extensions like your JPEGs, your MP4s, your MPEGs, they just tell .py, they just tell the computer which software you need to use to actually open it. So they're just telling you use Tawny. They're just telling you use Word. That's all they tell you to do. Okay, the operating system is actually responsible for the management of the file, for organizing the data into usable hierarchies, directories, subdirectories, files, subfiles, folders, subfolders, all that type of thing. Okay, it also deals with the moving and the editing and the deletion of data as it moves through the systems. Okay, the hard disk is also managed by the OS. It does make sense. Okay, it splits the physical disk into storage sectors if we're using that type of disks. Okay, it decides which sector is to write data to and keeps track of the free space on the disk. Okay, ideally, like data for a single file would be put in, adjacent sectors so that's easy to read, but it isn't always possible. Okay, and we'll have a look at that in the next video when we're talking about defragmentation. Okay, the operating system can also include things like utility software, okay, file compression software, and encryption software, and then defragmentation software. Okay, so it does all these things. Okay, file compression is not really something we talk about too much on in the Leave Insert, but basically, file compression is a way of taking out the extraneous detail in order to compress a file. Now you do lose. There is two types: one where you lose stuff and one where you don't lose stuff. But it's one of those things we don't really talk about, just to kind of know why you would decompress a file. You decompress a file in order to gain more space, But there is a kind of a trade-off. Decompressing or compressing a file, you lose a certain amount, especially if it's of a higher end quality file, like for example, movie or video and stuff like that. If it's a lower end file, for example, trying to think, simple kind of Word or Python programs and stuff like that, you don't lose really anything by decompressing and compressing. It's not that hard. So one of the ones we would have come across an awful lot would be, I don't know if you remember it from the old days of computers, File Explorer. You can still get into the File Explorer on a computer, but most people just don't tend to use it anymore. But File Explorer is kind of what you would remember. You'd have on the left-hand side all your files, and then you click on a file, you get more files, and you get subfolders. That was the old-fashioned file. That's utility software built into the operating system. That's what it is. That's what it does, really. Okay, and I suppose the last thing that an operating system does, it deals with accounts. Okay, so you can have what's called single user or multi-user accounts. Okay, so single user operating systems allow only one user to use the computer at once. Okay, most operating systems such as iOS, OS X, Windows 10 are single user operating system. Even if they have multiple user accounts or is connected to a network, there's still one person can use it at one time. Okay, multiple user accounts, the only one I can think of would be Unix. Okay, it's a server type of operating system. Allow multiple users to use the same computer at the same time. They're often used on mainframes. I don't know if you understand that word. So these would be giant computers, maybe in companies or in industry, and they give multiple users access to the same machine. The one example I can think of where you probably would use it is an ATM. Okay. ATMs are basically embedded systems. They're very simple, but an ATM is basically a portal into one giant computer, the bank's computer. So you can have multiple ATMs all feeding into the one computer system, and they can all access it at the same time. So, one person doesn't have to log out for another person to put their PIN in. They can all do it at the same time. So that's what we mean by a multi-user. We don't use. So it's a very important idea to get across to you, the difference between a single user operating system, which is most operating systems. It's your OS, it's your Windows, okay, and then your multi-user system, which would be your Unix and your. Now, I suppose a caveat to be done on that would be cloud-based systems probably don't have that issue as much. For example, with something like Android, it's probably possible to have two phones, both with your Android accounts on them, and to be able to access your email from both devices at the same time. Okay? Because they're not working off the same kind of principle. It's cloud-based, so you're kind of coming down into this system. This is all in the cloud, so you can have multiple devices from the same cloud. You're probably coming more into that kind of realm with your kind of Android and your online operating system, or your portable operating system, whereas your kind of standard ones for your PCs and laptops are probably more likely to be working in a single user system, okay, as it were, okay? So the operating system is also responsible for user account control, so how to get access to the computer. Most operating systems nowadays, personal data desktop, but they can't use other users' personal data or desktop, you know, that type of way. Once you could have anti-theft measures for PIN, password, specific patterns on the screen, fingerprint, retina scan. These are all coming into these biometric scanning devices. Okay, so yeah, so that's the way I think of that. Yeah. The more I think about it, I think the best way to distinguish between single user and multi-user is multi-user would mean that, for example, the Chromebook I have in front of me, multi-user would mean that two people could use this Chromebook simultaneously, and they can't. So it's not a multi-user. Okay? It's a single user. That's the kind of thing we're thinking of. Okay? So even though I was thinking about this for the cloud, I don't think it works the exact same way. So a multi-user system has to be a dedicated system where multiple entry points can be gotten to the same connection. So all those different ATMs could be, you know, different keyboards, for want of it, connected to the same screen. That's what we're talking about, really, in a kind of in a very generic sense. So I hope that kind of makes sense to you, the difference between the two types. Okay, thank you very much. Goodbye.